So I'm guessing you're here to see how it's possible to show that the colored angles of this cyclic polygon add up to 360 degrees. I mean, for some of you, it probably looks impossible, but by the end of this video, you'll have a clear understanding of why this must be the case. We'll begin by examining the shape. Clearly, this is a cyclic polygon because each vertex sits on the edge of the circle. Next, you should be able to see that it is a six-sided polygon, 1, 2, 3, 4, 5, 6. On top of that, it's an irregular polygon. As you can clearly see, the sides are not of the same length. And finally, one that's a little bit harder to see, and that is that in a way, each line joins the opposite vertex. And that results in the six-sided polygon being divided into two quadrilaterals. We'll show this more clearly later on and explain why this is useful to us. Oh, and there's one more thing I forgot to mention, and that is no two colored angles are adjacent. These are alternate angles. So what we're really saying is the sum of alternate angles is 360 degrees. So let's see if we can show why this must be so. We'll begin with just the circle and the cyclic polygon. Now we can start by figuring out the sum of angles in this shape. And that is very easy to do if we join two opposite corners with a line. Now this line results in two shapes, and you can see that each shape is a quadrilateral. We know the sum of angles in a quadrilateral is 360. The six-sided shape is made up of two quadrilaterals, which means that the sum of the angles must be 2 times 360, which is 720 degrees. I'm now going to add another line joining two other opposite corners. Now we can see that the lines intersect, and that opposite each intersection, both lines are connected by the same polygon edge. Let's hide the rest of the polygon edges for the moment, and I want to examine the angles in between these two intersecting lines. I'm going to pick one of the angles, it doesn't matter which one, and label that angle with an A. But there's another angle which must have the value of A. The angle A is created by the distance between 2 points, that is the distance between the right side of the top edge and the right side of the bottom edge. But there's another angle that's created by the distance between these 2 points, and it is this angle here. So the value of that angle must also be A. I'll call the angle that's adjacent to the first A B, and the angle B is created by the distance between the left side of the top edge and the left side of the bottom edge. And hopefully you can see that this other angle is equivalent to B because this angle is created by the same distance, so this angle must be B. Let's add in the rest of the edges of the polygon. So we now have 4 angles. Let's see if we can find the rest. I'm going to add one more line which will join the remaining 2 vertexes. Now things are getting a little more confusing, so I'm going to highlight an intersecting pair of inner lines that we haven't dealt with yet. Again, we can see that opposite the intersects, the 2 lines are joined to the same polygon edge. I'm going to hide 2 of the polygon edges this time, and I'm going to introduce 4 angles between the highlighted intersecting lines. I'm going to label one of the top angles with the letter C. Now you should recognize that this angle C is created by the distance between this point and this point, but that there's another angle that's created by this same distance. It's this angle. So this angle must have the value of C also. I'm going to label the other top angle with a D, and by now I'm sure you understand why this angle at the bottom must have the value of D. Both angles are created by the distance between this point and this point. Now there's just one more pair of intersecting lines which we haven't covered, and there they are. We can add back in the rest of the polygon edges, and there are just 4 more angles for us to work on. And I'll make this one extra easy for you by highlighting the 2 edges in the same color as the intersecting lines, and that should make it super easy for us to handle the remaining 4 angles. I'm going to label this angle with an E, and it should be clear by now that within this shape this angle must also be E, and that just leaves us 1 pair of angles. I'm going to label this bottom one F, and this angle must have the same value and so we have all of the angle values for the cyclic polygon. And now that we have all these angles, we can show why the sum of alternate angles in this cyclic polygon must add up to 360 degrees. I'm going to highlight one of the diagonals. Now take a look at all of the angles above this line. They are A, B, C, D, and E and F. What is the sum of all these angles? Remember that when we draw a diagonal, it divides the shape into two quadrilaterals. So this is a quadrilateral, which means that the sum of its angles must be 360 degrees. So A plus B plus C plus D plus E plus F must add up to 360 degrees. But now let's just pick one angle and then choose all of the alternate angles related to it. So let's start with the A. We miss this angle. This is the alternate angle. We miss this one. This is the alternate. This is the alternate. This is the alternate angle. And this is the alternate angle. Now let's list the angles we pointed to. We had A, we had D, we had F, we had B, C, and E. Clearly they are alternate angles because we've skipped one every time. But what are these angles? We have A and B and C and D and E and F, which means the alternate angles are A, B, C, D, E and F. So clearly the sum of the alternate angles equals 360 degrees, which is exactly what we were trying to show from the beginning. And just in case you have any doubt that these are in fact alternate angles, I'll show you the positions of the original alternate angles with their colors. And if you look at those angles, you can see that they are A, B, C, D, E, and F. So the sum of the colored alternate angles is 360 degrees. And we saw that the sum of colorless alternate angles was 360 degrees. And of course that makes sense, because if you add one of the sums of alternate angles to the other sum of alternate angles, you get 360 plus 360, which was the sum of all the angles in the cyclic polygon. And so that's how we know that the sum of alternate angles in this polygon is 360 degrees. Anyway, that's it for now. Thank you for watching.